to my talk. My name is Ronan Barrett. I work for Ericsson. Basically, the idea of my talk today is to kind of give some feedback to you guys here about what's actually been used in industry, specifically within Ericsson. So over the course of this conference and previous ones I've been to, we've seen lots of very interesting modeling tools, lots of interesting projects, but it's very hard to know what exactly people are actually using in industry today, what they actually think of the projects, what they think could be better. Yeah, so basically to give our feedback into what you guys can do. So most of it's good. There's only some minor negative issues, shall I say. So this is really a kind of the use case for the tool that we built in my particular department. It's basically a modeling tool where we model thousands of different classes, potentially thousands or 10,000s more potentially of properties. And the real idea is to create what's called an O&M interface. So this is operations and maintenance interface. So all these different parts of a mobile network or non-mobile network have various different managed elements, and we need to be able to control these. So each one of these particular elements has an interface, so we can control, for example, upgrading the software, fixing faults which occur, trying to get performance information off them, or perhaps tweaking the actual running system to improve its performance in some way or form. Or perhaps we want to turn on some additional logging within the actual nodes so we can actually see if there's why a particular problem is actually occurring. So we basically have models for all these various different network elements. There's over 100 of these at least, and they all have quite large models, and we have to be able to model these in some way. And so we have some tools which we create to help our internal engineers actually do this modeling. So our tools aren't actually used by people outside of Ericsson. It's all kind of internal stuff. But that means we get to play with lots of kind of cool Eclipse-based technologies, because we have kind of a closed environment which we can test these things on. Yeah, so this is pretty much the tool that we build. In the orange box over there, we have kind of what the user essentially sees. These are the DSLs that we're encoding to allow the user to actually create their O&M operations and maintenance models. I'll go into each one of these boxes in detail as we go through the presentation. Then inside the blue boxes at the top, we have the kind of the target DSLs, the things we have to actually generate off these DSLs in the orange box. So we use some different technologies there. We've started to use Xtext in the last year to create these kind of text-based DSLs. Otherwise, we use kind of Ecore-based models, whether creating them directly through a tree browser or else taking an XML schema or even a DTD and then importing it into the wizard to actually create the Ecore DSL. And to control going from these kind of high-level DSLs to the kind of the lower-level DSLs, we have lots and lots of model transformations. We use some different technologies. For example, we use Atlas Transformation Language for model-to-model transformations. We also have some model-to-text transformations as well using JET. And we've also started to use Acceleo lately as well. So as we go through the presentation, I will talk about each one of these Eclipse technologies and exactly what we think is good, what things could actually be improved as well. Yeah, so the tool basically is comprised of all these various different parts which create plugins to create the entire tool, and then we have these O&M interfaces which can be deployed onto these network elements so customers and people can change things. Yep. So first of all, how do we create the DSLs that essentially the user will be interacting with? First of all, we've got these really quite boring abstract syntaxes, which are often Word documents, which are really, really large, talking about all the different things which are important for O&M interfaces. These can be 100 pages long, and the chevron there indicates kind of what the static semantics of these DSLs are. So we have to basically encode all these meta models to create something concrete which the user can actually interact with when they're actually using the tool. So we currently use two different technologies. We're using IBM RSA to actually have a UML modeling tool, and we also have a third-party tool which we get from a company called Docus, which is called a Meta Model Agent. So the reasons we use these particular tools and not something that's an open source is because these are particularly robust and they do the job that we require. So the reason why we have two different models here at the top is the first one is the profile, which basically allows us to obviously customize UML to provide some extra stereotypes and properties, so we can actually put in these important extra meta model features onto our models. But then we also need some things which profiles can't do. Profiles can't say that, for example, a package can contain a particular number of classes with a particular stereotype. You can do that with OCL, but then you have to create lots of tooling which also matches up to those particular OCL constraints, which is really difficult. So what we do instead is we use this third-party tool which actually lets us, using UML, define what these actual constraints are between the various different parts of the profile. So these models are actually UML as well. So all of the stuff underneath is Eclipse UML2. So we're using the stuff from open source here, but sometimes it happens to be with a third-party product if that fits the bill. Again, this meta model agent can't express everything, and if there's a really complex rule or semantic which we want to implement, then we use OCL for that. So from these various different tools, we then generate a whole bunch of plugins. So we get the usual UML profile, we get this extra UML guideline, which comes from the meta model agent. We get some menus, so when the user is actually using our tool, they constantly see context-specific menus. So it checks against the meta model to see if you've already created, say, for example, 3 classes with a particular stereotype, and there might be a rule saying that you can only have 3, so it'll take away that particular menu item from the wizard. So the wizards are constantly checking your model against what is allowed inside our guideline model. So to encode those kind of things ourselves would be extremely laborious. So that's why we have these models which basically drive the entire code generation for these menus. Then the wizards do just the same. The wizards are able to read our guideline models and able to figure out, okay, if you're creating this particular element, then you probably want some of these, and you probably want some of these, and it'll actually help the user, give them guidelines and feedback while they're actually doing these things. And because of that, then you can also get some validation and some quick fixes as well. So it's constantly reading the meta model. It knows that if you've made a mistake, potentially how it can actually try and fix it. And we also have spent a lot of time over the last year looking at Papyrus. So Papyrus is a potential replacement for RSA. So we've put lots of requirements on Papyrus. We're also involved in a kind of a fund sharing where we pay for some features to be implemented, so that potentially we could at some point move to Papyrus when it's ready, when it's stable. So there's some interesting stuff going on there. So to give you some kind of feedback on how this process currently works for creating these DSLs is that although we can get lots of nice code generation and wizards and kind of feedback and guidelines, these actual guideline models are quite complicated to create. There's a lot of UML going on there. It's quite intense, kind of intensely large models to be able to make the tool intelligent enough to help the user in the ways that we want. Also, because we're using RSA, it has their own specific way of exporting UML profiles, and they don't work. They're some GMF path map. They won't work with a lot of Eclipse tools. So what we have to do is we have to explicitly use this URI mapping. And once we do that, then these profiles are available to all the model-to-model, model-to-text transformation tools. So it's just it's a thing that you often get when you start using, say, RSA or some other third-party tool, is that you might think it doesn't work with Eclipse technologies out of the box. So you have to do some little extra tweaks to get these things to work. So it's useful to know. One of the reasons why we can't take Papyrus right now is there's no Papyrus and OCL integration. So there's an open bug on that one, which should be fixed early next year. Once we have that, then we're quite far into being able to look at using Papyrus. And they currently also have some usability issues. So they're currently working on documenting a lot of the actual tool itself. So a tool without good documentation isn't really usable for our customers, because then they'll just end up asking me, or I'd ask someone else in the team. So we really need really good documentation before we can start using these tools. So some good things. These meta models, these guideline models, which I said were quite complicated to create, but they're complicated, but they're really extensible. So often we have meta models which actually have other meta models which try to reuse some of the stuff in the first meta model. And then they extend them, and they have other ones which then extend those ones. So there's a whole stack of extra kind of meta models depending on what it is that we're trying to generate. So this tool is able to extend existing meta models using UML, using standard inheritance, and we can get really, really good reuse of the guideline models. Yeah, as I said before, we get context-sensitive menus. This would be really, really difficult to hand code, but because it's model-driven, it's quite good. We don't have to write so many customization plugins. Because we don't have such a large team, it would be a lot of work for us to do all the customizations that you often get if you use the UML tool out of the box. So having a lot of these plugins built for us means that we can concentrate on the tasks of writing these guideline models, these meta models and these transformations, because that's the core of the tool. It's not to create nice GUIs. We want to reuse the GUIs which are available to us out of the box. A really great thing is that we actually are able to buy in or pay for third-party tools, and they do work with the Eclipse stuff which is being created in this community. And that's really, really great for us. So we can pick and choose what we need to pay for, or we can take open source if applicable. That's really, really good. And final thing there is that we're really looking forward to having a really good Papyrus, hopefully within the next release. Yep. So some of our kind of how we use DSL grammars. Again, we've got these kind of abstract syntax again with some static semantics. In this case, we encode them using Xtext. So we're not actually expecting the user to directly interact with these particular DSLs, but we want to be able to generate them as output models. So the UML models will go through some transformations which will then generate these particular textual DSLs. And so we basically have two things. We create the syntax in Xtext, and then we also create a formatter which guarantees that we get the output looking exactly the way it should to be compliant with the syntax. Some really nice things we get from using Xtext are that we get the Ecore DSL behind the scenes. So even though we're writing in as text, we're actually getting a meta model behind that, which we can use as our target for the model-to-model transformations. We get serialization, which is really, really useful. To write serializers yourself is really quite painful, but if you've got an Xtext grammar with associated Ecore model, you can just basically leave Xtext to perform the serialization for you. Then also you get deserializations where you can actually read up the grammars and actually then have an Ecore representation of those particular models. We can also validate that what we've generated is compliant to the syntax. So once we run the transformation, we can then call a validation to make sure what we've generated is correct. And also we can have some quick fixes as well. Yep. So some kind of feedback on our experience with Xtext. First of all is if you have a very large grammar, to write the actual formatter can be a little bit difficult. You have to write quite a lot of code to get the output to look exactly as you want. But in the latest release of Xtext, they've much improved this, where they've got kind of pattern matchers, where you can seriously reduce the amount of code you need in these formatters to get the output looking the way I like. So that's a good thing. And the other thing is that there's lots of layers within Xtext. So although we haven't experienced this yet, where something has gone horribly wrong and we had to kind of debug it, there's lots. It's quite involved inside there, so that's kind of one potential issue. But like I say, we haven't had a major issue with that yet. Some good things about Xtext is the documentation and tutorials are really, really good. It's possibly the best of all the Eclipse modeling projects. And that's exactly what we need as kind of people who don't want to be explaining how to use these things to our kind of guys in our team. We want them to be able to read the documentation, not have to find out for themselves. So it's really, really good. It's really easy to get into using Xtext, which is excellent. Yes, we get these resource serializations, so we don't have to write these ourselves. These come out of the box from Xtext, which is great. We've got seamless integration with model-to-model transformations and model-to-text transformations. So we can actually use the Ecore model, which is behind the Xtext grammar, to actually have a target for our transformations. That works really good. Xtext supports the static analysis of the models we generate, so we can validate that we've actually generated something which is useful. And then finally, Xtext comes with the model workflow engine and Maven integration, so we can actually have a complete headless build system, which I'll show you later on. And that's one of our key requirements now, is that we won't take on projects which don't have this facility. We don't want to have to kind of build stuff manually or check in compile code, which used to be the case with some of the kind of some of the projects. So this has been a very good experience. Yeah. So yeah, we do spend most of our time actually writing model-to-model transformations. So taking these UML models with lots of profiles and generating some output. So we've three kind of categories of model-to-model transformations. First one is we have these what we call refinements. So here we have a UML model coming in, and we do some minor adjustments to it. ATL has a refinement mode, but only up to the last release, I think, they actually allowed you to delete elements. So that meant that we couldn't actually use their inbuilt refinement mode. So what we do is we've got what's called a higher order transformation. This is basically an ATL transformation which generates another ATL transformation. It's capable of reading the entire UML2 meta model and copying elements from source into target. So we then get a ATL transformation which we can then modify to actually put in the particular refinements that we actually require. So this is really, really useful, because we can make very tiny adjustments which we need to do between our UML models. Sometimes we have to do some special things. Second type we have is these reverse engineering. Here we take in models which were built with older tools that we have in Ericsson. So we've had O&M interfaces for as long as we've had network elements. So we have to take in these existing models and actually transform them into something that are new, or this tool can actually read. We often perform model merge on these, whereby we have multiple input models which happen to represent the same structure, and we can actually compress that down into one, so that the resulting model is actually simpler to read than the models which came in. So when I say XML here, it actually means that we've got we've got an EMF binding to these. We've got some schema or some DTD, and we've imported that into EMF, so we can actually serialize these models and then run ATL on them. And then the final example here is this is the most common format of or type of model-to-model transformation. Here we take the UML model, we write some transformations, and we generate some either XML, or in this case we've also got some JSON stuff here. We can also generate some Xtext grammars as well. So these are just normal model-to-model transformations. So to give you some feedback on ATL, first of all, some kind of bad things, I guess. The reason why I have quite a lot of points here is because we've been using this for many years, so we've got quite a lot of experience with it. Debugging can be a little bit difficult. Sometimes you end up putting debug statements into your transformations. That's because you don't necessarily know when rules are going to be called within ATL. It's not guaranteed that the order is predetermined, so it'll be a little bit difficult to debug. Sometimes the error messages are completely cryptic. For example, if you forget to put stereotypes onto places where you should have, you'll get some really weird errors. So it's a bit of a learning curve into knowing what those errors actually mean. They're consistently the same errors, but they don't tell you exactly what's wrong. We've had a minor problem with the latest version of ATL, where we do some reverse engineering transformations, which the data has some very, very large integer values inside them, and it doesn't compile properly. Also, ATL has some do rules, and these do rules require you to return a value. If you don't, you get a crazy error. It's just a peculiarity of the language, but it could be done without, I guess. Also, ATL don't keep their update side up to date. They've got lots of new versions in the last 6 months, but they don't put them up on the update side, which I'm not too sure why. And the final thing is that not so many people know OCL, which means not so many people know ATL. So the user community isn't as big as it could be. But the really great thing about OCL and the really great thing about ATL is the language is really succinct. It's a very small amount of code can do really, really powerful transformations. So that's really the reason why we actually use it. So the language is set-based as well, so we can perform lots of set-based operations, and again, very small amount of code, we can do some really, really powerful stuff. As I showed you in the previous slide, it supports higher order transformations. So ATL has an Ecore model behind it, so ATL can generate ATL, which is really, really quite nice. Again, we've got a really good user guide here again with ATL, so it's quite accessible to people if they want to use the language. It's very well described. It's very stable. These issues here are the biggest issues I could find, and I've been using it for about 6 years, so it's really quite stable. It works really well with UML2, so most of our transformations have UML2 involved at some point, and it works really good. And I think the key point, the most important one, is the code when you write it is really, really maintainable. Compared to how much code you would have to write, say, if you're using something like Jet, it's a tiny percentage of it, and it's much easier to maintain. So lots of good things there. Then we also have model-to-text transformations. So we don't use model-to-model the whole time. If it's going to be a very kind of complex output model, such as C++ or Java, then we often choose to use a different language to actually write our transformations. The first one there, we use Acceleo to generate some C++ output. We've got some legacy transformations which use Jet to generate some Java. So some feedback on that. The biggest issue we've had with Acceleo is it seems to be, when we run our transformations, it seems to cause a change to the ePackage registry. And when things are changed in the ePackage registry, it then causes that other transformations won't run properly after that. So we've been forced to kind of copy the package registry before Acceleo runs, and then restore it straight after, so the rest of the transformations can still run. So we found a bug on this one, and we'll see where that one goes. The main reason we don't use Jet anymore is that the code is really, really verbose, and it's so hard to maintain. It gives me a headache even looking at it. And also, Jet doesn't work outside of Eclipse. It doesn't work properly. It's a known issue, so you can't get headless builds working. So you're going to have to check in your compiled code, and that's never a good idea. Also, doesn't mean any kind of major releases since 3 years ago. So some good things. So the reasons why we've decided to use Acceleo now is that the MTL, so that's the extension that they use. The code there is really quite easy to read, really nice to maintain. The editor is really good code completion for UML2. It integrates properly with Maven, so that ticks the box from that perspective. It's based on an OMG standard, so it's been well thought through, maybe too well thought through, but it's got good documentation as well, and lots of it. And I thought I'd say one thing nice about Jet is it's easy to write if you know JSP. So, yeah. So then how do we actually test the models? So we've got all these transformations, and it's really, really important that we don't screw up when we put in a new feature into these transformations. So we have to guarantee that the code and the transformations are always backwards compatible. They can add in new things, but they can't break the existing code. So for that, what we've done is we've created a very large amount of input test models. We try with these test models to express all the different possibilities. We don't have them all, but as many as possible of input models to go into the actual into our JUnit test cases. Then what we do is we've got a set of what's called golden files, and these golden files are output that we know is correct. We know the transformer worked when it created this. So we can basically run a whole bunch of regression tests every time there's a code check-in, and it will retest against these input models against the golden files. So this works really well. Often we're checking against XML, so we've got a custom parser there which doesn't care about the order that things are outputted, because that doesn't matter for us, but it cares that elements are created correctly and that they contain the right output. And then, for example, if we create things like Java, we check to make sure the Java compiles correctly. If we generate something related to Xtext, we check to make sure that the output there is valid according to the grammar. But we could potentially add in some new things here as well, such as having kind of randomly seeded input. So there's been some pretty interesting talks the last few days about stuff like that, so we could potentially improve that as well. But right now, this works good. We can see exactly the transforms are running correctly by using JUnit and creating these test reports. Yeah. So then finally, second lastly, we have a whole kind of build automation behind all this. So it became a real pain constantly updating our releases manually. So we invested quite a lot of time into how we could use Jenkins and Maven and Tycho and Surefire and get all these things coming together to actually be able to build all our plugins, run all our test cases, and make sure everything is actually running. So right now we have Jenkins kind of configured to check for some changes in the source code management, then obviously retrieve the code, retrieve the configuration files, then hand over to Maven, and Tycho will then actually build all of our plugins. It'll go to our remote P2 or network disk to actually retrieve all the dependencies. So because we don't use only just open source Eclipse projects, we also use some third-party tools. We have to install those third-party tools into somewhere on a network disk as well. So all these things can be retrieved. So like things like RSA can be retrieved, and Meta Model Agent can be retrieved, as well as all the kind of Xtext and ATL and these kind of things. Then we also have Surefire. So Surefire allows us to actually run all the test cases that we have. We obviously have to make sure that after every single change, our ATL code or our whatever transformation code that we haven't broken the existing code base. So yeah, we run these guys and we basically check to make sure everything's okay. If everything's okay, then we end up building these the P2 repository. And our next step is that we're going to then automatically push that then up onto our nightly build server, where people, our customers, can test out the latest versions of all the different plugins and say if they're happy or not with them. Yeah, so some kind of final observations, I guess. One thing we've seen from other talks today related to Maven and Tycho is that the dependency issues is quite difficult to figure out. Other people have mentioned the fact that model dependencies are also a bit of a problem. If I have a UML model which uses a various number of different profiles, those profiles and their plugins have to be mentioned inside the manifest MF. If they're not, when Surefire runs those test cases, they're all going to fail. And it's really, really difficult to figure that out. We spent quite a lot of time constantly rebuilding the systems to try and figure out why these particular test cases failing. So yeah, end up printing out class paths and these kind of things. So every single model dependency has to be explicitly defined inside your manifest. If you don't do that, it's just not going to work. And that's a very irritating issue, but that's a modeling thing. Another thing which probably, I don't know, maybe isn't appreciated here, but for people who are coming in to modeling and they're quite new to this, is quite a large barrier of entry into EMF. We all understand EMF, we all understand modeling, but it's still quite complex for new people. When we take new people on, it's difficult to kind of get them into the mindset of using EMF, and I think that's something we should always be kind of aware of. Something that used to be quite difficult, but we don't have such a problem with this anymore now that we're using things like Xtext, is that resource factories, so the ability to actually serialize your models correctly is quite difficult. We can't always use XML schemas. We sometimes have to use DTDs because we've got some really kind of legacy systems we have to generate interfaces for. And it's really quite difficult to get the exact output of a DTD header inside an XML output. It's really, really difficult. So those things are a bit of a pain, but that's maybe legacy stuff. Another thing, I guess, is inconsistent quality of documentation. As I said before, for kind of companies to use plugins and projects, we really, really need good documentation. If we don't have that, we end up answering all the questions, and it's a real pain. And it's a great way to advertise your project, is have good documentation. So a lot of projects do, some don't. Sometimes we miss roadmaps. Sometimes it's kind of a little bit difficult to know when, say, a new kind of killer feature is going to be implemented. So we're not too sure when we can take this, but I guess this is true for everybody. And also, we're not too clear when and if we file bugs, or if anyone file bugs, when those things are going to be fixed as well. So these are general kind of communication issues that every project has, but they're things which maybe hold people back from taking on a project or taking on some tools. But then some really good stuff. Yeah, like I said, we spent the last 6 months part-time trying to get all of our tools to run on Tycho, Maven, Junit, and it all works except for Jet. So we can. Yeah, we're really, really pleased that this stuff works. It's really kind of showing that this stuff is really kind of industry grade, industry standard stuff. So that's really, really good. And like I said before, a lot of the kind of modeling projects we've been using, the quality is really, really exceptional, and that's fantastic. Another cool thing is that we have in our team, it's quite small, but because we're using lots of these modeling tools and we're actually using models to actually generate the tool itself, we can actually be a really kind of small team and actually generate everything we need to actually meet the customer's requirements. So I think we're achieving really good efficiency by using the Eclipse modeling stuff, which is great. Another really important point is that newer versions of projects, newer versions of Eclipse tools actually work with older versions of Eclipse. So because we can't always take the latest and greatest, we can't take Junit just yet because we're using IBM ORSA, which is 2 versions back. It's on 3.6.2. So if we're going to take, say, the new version of Xtext, we have to be sure that that works with 3.6.2. And any of the projects which we're actually using today, they do. They all work, which is really, really good. So they're not say, kind of bringing in kind of new dependencies, which is forcing us to upgrade the platform underneath, which is excellent. Which, yeah, relates back to one of the talks earlier on, talking about how reliable and how kind of well-written EMF actually is underneath. So we're seeing the benefits of that here. Yeah, another thing is that with using Eclipse UML2, we're getting some really good kind of tool interoperability. So we're using ORSA today, but tomorrow we could use another Eclipse-based tool, like something like Papyrus or something else, because we're not relying on XMI as being the kind of commonality. We're using Eclipse UML2 underneath the hood, so we can actually push these models onto potentially a new tool and use a new GUI if that was needed. And again, we're seeing that third-party tools are actually taking Eclipse projects, and we're able to then kind of switch around and pick and choose what we actually want to use. Yeah, finally, industry are actually involved in kind of Eclipse modeling. We have this Papyrus collaboration whereby Ericsson and some other companies are coming together to basically come up with a global list of requirements which we feel need to be implemented to bring Eclipse modeling more into our tooling. And obviously we pay money for this, and we then get involved and get kind of hands-on with the various different people who are involved in committing to the project. So I think this is a really good kind of like two-way process between industry and people who are actually committing to the various different projects. Yes. So, any questions? Yep. Yeah, so how do we compare the golden files? Basically, we take in the outputs of the transformations, put them into a DOM parser, and then also take in the golden file into the DOM parser and compare the two. And we have some rules inside this DOM parser to say that we don't care about order, but we do care about every single element has to be there, every single attribute has to be there, those kind of things. So it's just basically a comparison of some kind. But it works. Any other questions? No? Okay, thanks very much for listening.